Hello everyone, this is our EE599 project. So we are going to generate faces from sketches and alternate features using generative adversarial networks. So our objective is to produce a real photo from sketches and changing the feature for those photos. You can see from the picture below. First, we start with the sketches and then get a real photo, and then we try to alternate the features on the faces from the glasses to non-glasses. So our network gonna have two parts. The first part is the pic-to-pics, which is a conditional GAN network, and the second part is attribute GAN network. So the pics-to-pics is used to translate the sketches to the real pictures. So when we get those generated images as input to the second one, which will be the input to the second network, and then we're using the attribute GAN to edit the various features of the image. So first we'll start with generative adversary network. Which consists of two parts, a generator and a discriminator. Generator is used to generate real-looking images, and the discriminator is to identify which image is real and which images is fake. Here we comes to the first part of the network. So similar to the original GAN, the conditional GAN is composed of a generator and a discriminator. In an unconditional generative model, there is no control on modes of the data being generated. In a conditional GAN, the generator learns to generate a fake sample with specific condition or characteristic rather than the generic sample from unknown noise distribution. So in the figure below, you can clearly see the structure. So this is the result we get based on the model. You can see that the generated photo is pretty close to the actual one. And now we come to the second part of the network. So first we start with the IC GAN. So we train two encoders separately rather than just one. The first encodes the image to its latent space representation, and another one encodes the image to Y, which is the feature vector. And here you can see from the graph, we can alternate the features based on the label Y. Because the latent representation is sampled from the normal distribution independent of the attributes, but since the attributes demonstrate how an image will appear, its characteristic, this implies the relation between the attribute and the face latent representation is complex and dependent. Thus, the approach we employed in the IC GAN results in the loss of information, and hence lower image fidelity. So we try to modify that and introducing the attribute GAN. Instead of imposing an attribute-independent latent representation constraint, we apply the attribute classification constraint to the generated image, and then we just change the attributes which we desire. So compared to the IC GAN, the latent representation is constraint-free, which guarantees more flexible editing. And here is the architecture we use for the attribute GAN. Which is similar to the original paper. And one thing to mention is that we use the UNet structure to highly improve the result. So UNet structure is pretty much adding connection between different layers between encoder and decoder. So it's doing good in terms of preserving the locality of the image, and usually it is computationally efficient. And here is the final result we got From the sketches, we got the generated photo, and then we alternate the features. You can see that this is yellow hair, and this is from non-smell to smell. Yeah, this is the summary of our project, and we have posted the code and the model in the link below. Thanks for watching.